Welcome to solverfy.
In the given problem, we are told that the probability density for an electron in the region between 0 and XL for a one-dimensional potential well is given as psi square x is equal to b sine square kx. So let's write this down. So in case of a one-dimensional potential well, the probability density psi square x is given by the relation b square sine square kx. Okay, sorry, it's b. Now, given this information, we need to show that the wave function xi can actually be obtained from this equation if we start. So provided we start from this, we can actually obtain a solution for the Schrodinger's equation for this problem. So in order to do that, we'll first write down the Schrodinger equation for this region, and this becomes equal to d square xi over dx square. We'll notice one thing, that there is no potential. The potential is exactly equal to 0 in this region. So between 0 and L, the potential is equal to 0 plus 8 pi square m over h square E psi. E is the energy of the electron which is trapped inside. And we'll notice that E should be greater than 0. We start with this. So now let's take a root. So in that case, we get psi of x as equal to, taking root of b, we can either write this as root b, or let us say that root of b is equal to sum a. So I'll write this as a, and sine square is sine kx. Now we differentiate this 2 times, so we can differentiate the whole thing twice because we have d square psi by dx square. And when I differentiate this twice, d square psi over dx square, if I differentiate one, I get a cos function, and I differentiate the cos function again, I get another sine function with a minus sign. So we get a minus k square a sine kx. This is exactly equal to minus k square psi of x, which psi is a wave function. So we make this substitution in this equation in our main Schrodinger's equation. So this is a Schrodinger's equation. So in that case, we get minus k square psi plus 8 pi square m over h square E psi equal to 0. And if this equation overall is equal to 0, we see that k square should be equal to all of this. So now this gives us a solution that k square should be equal to 8 pi square m e over h square. So we see that this equation, starting with this, it actually solves our problem. We get k square equal to 8 pi m e over h square. And that also gives a solution for part B, because in part B we needed to find an expression for k that makes this true. So this is our expression, and the final expression for k can simply be written as k is equal to, if we take root of this is equal to plus or minus, because e is greater than 0, this overall value is actually greater than 0, so it's a positive value. And root of a positive value, there's no restriction, so it can be a positive number or a negative number. root 2me over h. So 2 pi root 2me over h.